Hello. Hello. Day 19. Go with the flow. I had a quick read through of this, and it seems that we're gonna continue our work from day 16. So I copied day 16's file over to day 19, so we can use that as a starting point. The main difference being that we now have an instruction pointer that is aliased to a register. We have 6 registers instead of 3, I think it was. Yeah, and we have the clear instructions, so no more guesswork. So I think the first thing I'm gonna do is just convert that to get rid of the codes. So I will have build actually use the name here, and then return that as a pair with a function, and then I can use a dictionary instead, I think. And since each thing is a pair of keys to things, then I should be getting a dictionary I can just look up. Yes, 3 or more opcode mapping. I just need to get the program directly. So we can do this instead, def parse line. And then if we have a quick look at, let's put it up there. Where do I, there. Let's do that. So there we have the instruction. So we basically have the first one being the opcode, and the registers is everything else. No, it's not the registers, it's A, B, C. We have the numbers of that line, and then the opcode should be... Yeah, I'm just... Should I look that up there, or should I just keep it as a string? Let's just grab it from that anyway. So we have return line split, and then take the first of that. Or I think I saw somewhere that we can do op and args. If we split that on that, but just the one chime, just one chime, then op should be the op, and then args should be the numbers, and then I can do op A, B, C. And then we just do one line in. So let's do lines equals lines. We get all the lines. The first one is the special one, a line, pop. What do you do, pop? So I think that's from the end, right? So then for line and the rest of the lines, we parse line, and we have program add that, and then the program is just a list. And then when we've done that, we help us out by printing it. We don't need to do that's sort of the rest of the thing. Registers, we have 2 more. That's 6 of them. And now we have instruction in the program. So let's say for up AB registers is found by looking up the instructions of the opcode and then calling that using that, and then tweak the yes. Then we just return those registers. Just print. This is still not adequate. So let's comment that out. Okay, let's go to day 19 and Python. List W has no attribute add. Oh. Add. I thought that was the name of the instruction. It's append. And there are not enough values in numbers. That's concerning. That's probably the pop thing. Pop. Let's just have a check on that one. And the list. Yes. Okay, an item. Do I need to specify that? Yes, because the default is the last one, so we say pop 0, fat fingers. Yes, so there we have the program, we get the register back. Then we need to parse our we need to parse the initial instruction pointer, and that is the register it's in. I think this is I just saw that yesterday. Let's try it out. As x equals 1. Yeah, that's what I'm thinking that's supposed to do. And if I have that, you get yes. That's too special. Yes. And then itbreg is now the value used for the instruction pointer. Then we have the actual instruction pointer starting at 0, and now we need to look at the instructions here while I drink some coffee. Opcode, program flow, instruction point, boundary register, through declaration to compensate for this 6 bounty in Britain. So I think we need to change this loop. So we do while if, so if we don't need until down here, and while if and I think we can do that, and then we get the instructions. This is the thing. We need the opcode A, B, C from the program. The IP. Last thing we do is we increment IP by 1. The thing is that we need to copy over IP here from the registers. IP reg, I think. Let's just verify this. When the instruction pointer is boundary, its value is written to that register just before each instruction is executed. Write to it just before each instruction is executed. Yeah, sure. No. Does this explode? Let's just dump out the state here on each. Do I need to write it back to the register? Okay. So we have that also. Okay, now stuff is happening at least. Why do we have a false in there? Let's not have a false. It's one of these. It's just annoying to see. Okay. Let's take the example program and let's create a new one. I think, yeah, never mind. Let's do the new one, new file, example. Okay, let's do that. Cancel that. Did it actually run with that sample or not? What's going on? Input. Okay. Then we had that something 656009. What are you printing? Each line is yeah, at the time the instructions start. Yeah, sure. Can do that. Okay, I think I have an issue there. Okay, so let's do exactly what they say here. When the instruction pointer is bound to register, its value is written to that register. That's what we're doing here. Just before each instruction is executed, yes. And the value of that register is written back to the instruction pointer immediately after each instruction finish execution. Yes, that's that line. Afterward, move to the next instruction by adding 1 to the instruction pointer. Yeah, so if you did a jump, we still add 1. And then we go again. Even if the value in the instruction pointer was just updated by an instruction. Well, you can't update the value in the instruction pointer, you update the register, but I guess that's what they mean. Even if you did a jump here, saying I want to go there, then we still update it before we do the jump. Yes. We start by 0. If the instruction body ever causes the device to attempt to learn instruction outside the instructions defined by the starts instead of the instruction starts as Yes, I think that should be correct. I'm not 100% sure about that. 1, 0 in range 1 to 10. So a program that's 10 long, 10 is not in, but 9 is. Yes, that's what I want. Okay, and the input. Let's skip the printing bit. So what the question is, what's the left? Register 0. What's left and register 0? That would be that 2280. Yes. Part 2. Okay, and we just do the tweak like that. And I'm guessing you're gonna have some issue with that. A new background process immediately spins up in its place. It appears identical upon closer inspection. It notes that this time register 0 started with the value 1. Okay, so IP didn't start with that. Yeah, so maybe now I need to see what's going on. When this new background process halts. This might be a case where you need to inspect something because it's like it might be that there's a loop just ticking. And then just subtracting manually or dividing or whatever. Yes, will it decrement that? That thing is annoying to read. Yeah, so here it's decrementing something, and when that hits a certain value, it might decrement something else. So let's see if C equals 0, print. So these are basically only the things that will change. Because we write in that register. Oh, geez. Okay, forget about that. But we also need a nicer way of printing stuff because I can't follow otherwise. So we have the instruction pointer. Let's do F of that. We have the instruction pointer. Let's have that be 2 digits. Then we have the registers. Oh, they are all. That's a map. R. And we say F. And we want to have. That's what? That's 8. 9 digits for each register. I need to make the list. Then we join. Is that a thing? Function object is not issuable. Registers. Just maximize that. sleep this, pause it. Well, it's incrementing that. This one is just popping back and forth. So I'm guessing that's what that is aliased to. And then this one is doing what? Is incrementing. So incrementing. I'm guessing that this is one of those cases where it's gonna increment up to a certain value, then change the register I'm interested in with 1, and then do that again. Did 1 just change? Okay, and let's only print FC in 0, 0, 1, 2, 3, 4. Those are the ones we're interested in. Let's also have this. Stupid autocomplete. Okay, so that doesn't seem to be happening. Can we just make a funny guess? How big is that and that? That is 10 million, right? That is also 10 million something. So let's say that we have take this number, I say that number minus subtract that one. So 88888. No, that's too low. So it's not the difference between those. I thought that maybe it would increment each time until it reaches that. Okay, this might just be easier to print out now. And then manually build. We have the name there. And we still have the name there. So we could just print out the instruction itself. So we print the actual instruction. And are they all the same length? Yes. I can just say print it like that. Let's make a new one so this one can be running in the background. Python that. Let's also include the okay, and then let's format the IP. So we have a loop here, right? Add set mult equal and set let's just it's ABC, right? So C is the last one. So add R. Let's add contents of register 2 maybe with 5 and then write that back to register 2. And then set the immediate. Yeah, I'm pretty sure I'm gonna have to grok that a bit. So let's tweak our thing. Can say 4. What happens if it's overflowing? Is it overflowing in a helpful way? Yes. So we have the IP that we already have up there. Let's just say IP like this. Then you have the ticks like that. Let's see if we can trace this. Let's do it from whoops. Let's make that a bit smaller so we have more context. That will be a full loop, I think. Or I guess we do that. So we have the IP there, we say multiply register. I need to, let's duplicate this tab, and then go to day 16 just to have the things here. So mul R multiply register stores into register C the result of multiplier is A. Okay, so that's a 2 register multiplier. So register 4 times 1. And we have register 0, 1. let's make this, let's move 3 more step, whoop, something like that. Okay. That's, why didn't I just print it? Okay. If we start by that. So we have 2 iterations. Then let's give ourselves some headers here. So we have if of A, B, C. That is if again. Then we have 0, 1, 2, 4, 5, 6, 6. Okay. That's what we have. Say 4 times 1. 4 times 1. Multiply 4. That in register 1. Store in register 5. You definitely don't do that. That does not seem to be happening. Do I see a pattern here? I should have printed the opcodes also. 13. One, 3, 6. Two, 3. Wobba. No, I'm not getting that directly. So in Python now we say multiply contents of register 4, which is that, with register 1, which is that. That's definitely not the value that we store in here. So how come? Oh, 0, 1, 2, 3, 4, 5. Yes, my bad. That makes more sense. So you multiply that by 4, 1, and store it in 5. Indeed you do. Are those registers equal? 5 and 3. That's equal register, right? Set register C to 1 if register A is equal to register otherwise. Okay. You set 5 to 1 if 5 and 3 are equal. And this seems to be incrementing in each run. Is 4 ever incremented? No. So you're gonna step that one up until that one is stepped up. Should we just hack our program here? Yeah. I'm thinking whether I should like translate this to C code and just see what's going on. So we say Addy. Yeah, I'm pretty sure it's one of those things going on. So we have Addy. Let's have that actually be that. Let's move these ones up here again. So add E is what we say. Add E is immediate integrates the result of a register and value B. So you say R2 equals RA, and RA is 2 plus 16, right? Set E is set immediate, stores value A, register C. So R4 equals 1. Set then again R4 equals 1. That would be, why did it do that? Set the But I think I still haven't found my exit condition to go out of that auto loop. Fine. So you're basically factorizing that thing. Oh, yeah. R1. Not 3 or 4 or right. If 4 R1. I must have missed the exit condition here because I don't see the exit condition. I'm guessing this is the exit condition, but I don't see when it ever goes to 25 other than the initialization. But R0 is 1 the first time around. R2 14. So it goes there, or you add that with this 1, and then you come down here, but then you go to 33, skipping over the exit condition. So what are we saying here? What factors does that have? Is that what I'm asking? But I just want 2 factors also. suppose we can move that thing around a bit. What is A? Can't we reword this a bit? Because all we're doing in this inner loop is incrementing that, and then incrementing that with whatever that was. And that only happens if R3, if you divide that by R1, I suppose we can tweak that condition. Okay. So we have the number itself first, right? So the first thing we can have in this loop is that when R4 is R3 and that is 1 and vice versa. The issue is I haven't even found the exit condition of that thing. So isn't that? That, I think. Isn't it that? Is that the number? Yay! But I still haven't found a terminating condition for my program. I haven't managed to figure that one out. Oh well, this is basically manual work, translating, looking at the program, trying to figure out what's going on, translating the instructions to high level things. Here I just did a notation change basically. And then here I try to move it up a level or two to convert the jumpings to loops. And then we have the initialization. So we basically have 4 loops. And it's the only thing I'm not satisfied with is that I can't find the exit condition of the outer loop. Because this is just running the program again. Well, I think I'm gonna leave it at that. Maybe poke around a bit more. Probably gonna check out the Reddit and see if I missed what that was. Because I don't think it doesn't look like it will terminate my program. And you see this is increasing extremely slowly. So I mean, running the thing just as is probably not an option. So you need to see what's going on. So here is the only place where I actually changed that register to anything interesting. But I don't know if I didn't copy this over correctly or something, but I don't see the exit condition. You're increasing. Yeah, never mind. I guess will be it for today. Thank you. See you tomorrow. Bye bye.